Students, in this video we will do some of the important questions from the exercise of chemical equilibrium. Right students? Now we will do the important questions. Let's see what first question is given to us. Here a reversible chemical reaction is given to us. That is the reaction of carbon monoxide with hydrogen to form methane and water. Right students? Now the first question which is given is write forward and reverse reaction for it. We are asked to write the forward reaction as well as reverse reaction for this chemical reaction. Now let's start students. First of all we will write the forward reaction, right students, and then we will write the reverse reaction. Now students, we have write the value of Kc or Kc expression, which is equivalent to, let's write the forward reaction. So carbon monoxide on reaction with 3 moles of hydrogen, right students, will form methane as well as water. We get 1 mole of methane, right students, plus 1 mole of water. This reaction proceeded from left to right hand side. I hope this is clear. Now students, we will write the reverse reaction. Reverse reaction. Now in the reverse reaction, methane and water becomes reactants, right students, while carbon monoxide and hydrogen becomes products. Now students, we will write the reverse reaction. In the reverse reaction, methane, 1 mole of methane on reaction with 1 mole of water, right students, will form 1 mole of carbon monoxide plus 3 moles of hydrogen. This reaction proceeded from right to left hand side. I hope this is clear to you students. Now students, we will see what next question is given to us. In the next question, we are asked to derive Kc expression for the given reaction, that is the reaction of carbon monoxide and hydrogen to form methane and water. We are asked to derive its Kc expression. Now students, as we know, what is Kc? Kc is the ratio of the product of the molar concentration of product to the product of the molar concentration of reactants. So we will write the Kc. Kc is equal to, we know what are the products of this reaction, methane and water. They are the products. So product should be written as numerator. CH4, we have 1 mole of methane as well as we have 1 mole of water. Products should be written as numerator in Kc expression, while reactants, they should be written as denominator. And we know what are reactants. Reactants are, we have 1 mole of methane, right students, and we have 3 moles of hydrogen. Since number of moles of hydrogen are 3, so 3 is written in the form of power. So this is the Kc expression for the given reaction. I hope this is clear to you. Now students, we will see what next question is given to us. In the next question, we are asked to determine the unit for Kc for this reaction. Right students, now we will determine the unit of Kc. Once again, we will write the Kc expression. We know very well what is Kc expression. Kc is equal to it is equal to CH4, right student, molar concentration of methane into molar concentration of water over molar concentration of carbon monoxide, right students, into molar concentration of hydrogen raised to the power 3. Concentration of methane into molar concentration of water over molar concentration of carbon monoxide into molar concentration of hydrogen raised to the power 3. Now students, we will write the values of molar concentration, that is moles per cubic decimeter, right students. So Kc is equal to for methane, mole per cubic decimeter, Similarly, for water, mole per cubic decimeter, right students? For carbon monoxide, we have mole per cubic decimeter, and for hydrogen, mole per cubic decimeter raised to the power 3, since we have 3 moles of hydrogen, or Kc is equal to mole per cubic decimeter, right students? 1 plus 1 is equal to 2, right students? And here mole per cubic decimeter, mole per cubic decimeter, right students? 3 plus 1 is equal to 4. Students, here we have noticed 1 plus 1 is equal to 2, right students? While 3 plus 1 is equal to 4, right students? Now we'll see what is the next step. In the next step, we will write Kc is equal to mole per cubic decimeter, right students? 2 minus 4, or it will be equivalent to mole per cubic decimeter minus 2. So Kc would be, the unit of Kc would be minus 2 multiplied by mole is equal to mole minus 2, and minus 2 multiplied by minus 3 is equal to dm6, right students? So what is the unit of Kc here? It is mole minus 2 dm6. I hope this question is clear to you students. Now students, we will see what is the next question. In the next question, a molecule is given to us, a chemical reaction is given to us, that is the decomposition of diatomic oxygen into ozone, conversion of diatomic molecule of oxygen into ozone, right students? Usually this reaction occurs during lightning storm. Diatomic molecule of oxygen is converted into a triatomic molecule of oxygen, which is known as ozone. Now student, what question is given to us? Here we are asked to write equilibrium constant expression. Equilibrium constant expression means we are asked to write Kc for this reaction. Now let's start the reaction. We write the Kc for this reaction. We know very well Kc is the ratio of the product of the molar concentration of product to the product of the molar concentration of reactants. Here, what is the product? Ozone is the product, right students? So product should be written in the form of numerator, while reactants, they are written as denominator, while the coefficient of the balance equation changes to power. So we'll write here the product, that is ozone. How many moles of ozone are there? We have 2 moles, right students? And over oxygen, O2, how many moles are given? 3 moles. So 3 should be written in the form of power. So this is Kc students. I hope this is clear. Now students, we will see what next question is given. In the next question, we are asked to determine the unit of equilibrium constant. It means we are asked to determine the unit of Kc. Now let's solve the question. अब हम इस question को solve करेंगे. Kc is equal to, we know very well, Kc is equal to, we write the value of Kc first of all. Kc is equal to O3 raised to the power 2 over O2, that is oxygen, raised to the power 3, right students? Now we will substitute the values. The values will be molar concentration of, in the form of mole per cubic decimeter, right students, raised to the power 2 over mole per cubic decimeter raised to the power 3, right students? Now we'll see what is the next step. In the next step, mole per Kc is equal to mole per cubic decimeter, right students? And here 2 minus 3. So we will have Kc is equal to mole per cubic decimeter. 2 minus 3 is equal to minus 1. Minus 1. Right, students? So we will multiply minus 1. We get the unit of Kc. Kc is equal to mole minus 1. dm cube. Mole minus 1 dm cube. So this is the unit of Kc. I hope this is clear to you, students. Now students, we will see what is the next question. In the next question, we are asked to write forward as well as reverse reaction. Forward and reverse reaction. Now first of all, we will write the forward reaction. Forward reaction. Forward reaction. Now students, we know what is the forward reaction. This is the conversion of diatomic molecule of oxygen into ozone. Right, students? So we write the forward reaction. Forward reaction usually proceeded from left to right side. We have 3 moles of oxygen, right, students, and they are converted into 2 moles of ozone. This is the forward reaction. Clear, students? Now we will write the reverse reaction. Usually reverse reaction is proceeded from right to left hand side. In the reverse reaction, ozone becomes reactant. Right, students? So we'll write the reverse reaction. Reverse reaction. Now what is the reverse reaction here, students? We have 2 moles of ozone. Right, students? They are converted into 3 moles of oxygen. So this is the reverse reaction. I hope this question is clear to you, students. Now students, we will see what next question is given to us. Here a question is in front of us, right, students, and we are asked to write equilibrium constant expression for each of the following reactions. Equilibrium constant expression for each. Now students, we will see what next question is given to us. In the next question, we are asked to write equilibrium constant expression for each of the following reactions. Some chemical reactions are given to us, right, students, and we are asked to write equilibrium constant expression. It means we are asked to write the value of Kc for the given reactions. Now let's start writing the value of Kc for the first reaction. The first reaction is the decomposition of water into hydrogen and oxygen. So we will write the Kc expression for the first reaction. Kc for this reaction is Kc is equal to, now what are the product for this reaction, students? The product should be written as numerator hydrogen, right, students? We have 1 mole of hydrogen and half mole of oxygen, O2, right, students, raised to the power half. And reactant of this equation should be written as numerator. What is the reactant here? Water, H2O. So this is the Kc expression for this reaction. I hope it is clear to you, students. Now students, we will see the next question. The next question is reaction of carbon monoxide with hydrogen to form methyl alcohol. We are asked to write Kc expression for this reaction. For this reaction, Kc will be equivalent to, Kc is equal to, what is the product of this reaction, students? Yes, this is methanol. So it should be written as numerator CH3OH, right, students? And reactants, they are written as denominator. What are the reactants? Carbon monoxide, right, students, and hydrogen. Number of moles of hydrogen are 2, so that's why 2 will be changed. It is changes to power, right, students? I hope Kc for this reaction is clear to you. Now we'll see what next question is given to us. In the next question, this is the decomposition of carbonyl chloride into carbon monoxide as well as chlorine, right, students? So we are asked to write the value of Kc for this reaction. Kc is equal to carbon monoxide, right, students? Kc is equal to carbon monoxide and chlorine. So we write here carbon monoxide into chlorine over, we have carbonyl chloride. Commonly this is known as phosgene gas. So this is the value of Kc for this given reaction. Now students, we will see what next question is given to us. Next is the reaction of hydrogen chloride with oxygen to form chlorine as well as water. Now students, we will write the Kc for this reaction. For this reaction, Kc is equal to, what are the product of this reaction students? Chlorine and water. So this should be written as numerator. Chlorine, how many moles of chlorine are given? 2. So 2 should be written in the form of power. 2 moles of hydrogen water, so 2 in the form of exponent or power. How many moles of HCl are given? 4. Right students? So 4 changes to power and we have 1 mole of chlorine. So this is the value of Kc for this reaction. I hope this value is clear to you students. Now students, we will see what next question is given to us. In the next question, we are asked to determine the unit of equilibrium constant for the following reaction. Determine the unit of equilibrium constant for the following reaction. It means we are asked to determine the unit of Kc for these reactions. Now let's start. What is the first reaction? It is the decomposition of carbonyl chloride into carbon monoxide as well as chlorine. So in order to determine the unit for this reaction, first of all we will write the value of Kc. हम सबसे पहले Kc की वैल्यू लिखेंगे स्टूडेंट्स. So Kc for this reaction is equal to, Kc is equal to, what are the products of this reaction? Carbon monoxide as well as chlorine. Right students? Divided by over carbonyl chloride, CoCl2. Now we will put their values in the terms of moles per cubic decimeter. Right students? So Kc is equal to mole per cubic decimeter, right students, into mole per cubic decimeter over mole per cubic decimeter for carbonyl chloride. Mole per cubic decimeter for carbonyl chloride. Right students? Now here we have 1 plus 1 is equal to 2. Right students? So we write here Kc is equal to mole per cubic decimeter, right students, 2 over mole per cubic decimeter. Right students? Now in the next step, what should be the next step students? In the next step, Kc is equal to mole per cubic decimeter 2 minus 1. Right students? So we will have mole per cubic decimeter 1. Or what is the unit of Kc for this reaction? The unit of Kc for this reaction is mole per cubic decimeter. This is the unit of Kc for this reaction. I hope this is clear to you students. Now students, we will see what next question is given. The next question which is given is the reaction of hydrogen and iodine to form hydrogen iodide. Right students? And we are asked to write the unit for Kc. In order to write the unit of Kc, first of all we will write the Kc expression. Kc is equal to, what is the product of this reaction students? Hydrogen iodide. How many moles are given? 2. So 2 should be written in the form of power, hydrogen into iodine. Reactants should be written as denominator. Now students, we substitute their values. Their values will be mole per cubic decimeter raised to the power 2, right students, over mole per cubic decimeter into mole per cubic decimeter. Right students? Now here students, you can notice 1 plus 1 is equal to 2. 1 plus 1 is equal to 2. Right, students? So here we write 2. So we'll see what is the next step, students. In the next step, Kc is equal to mole per cubic decimeter raised to the power 2 over mole per cubic decimeter raised to the power 2. Equal and opposites, right, students? So that's why they will be cancelled out. Both will be cancelled out. So in this case, Kc has no unit. Kc has no unit since the number of moles of reactants and products are equal. That's why Kc has no unit. Now students, we will see what next question is given to us. In the next question, the reaction of hydrogen with oxygen to form water. Right, students? And we are asked to write the unit of Kc for this reaction. Now in order to write the unit of Kc, first of all we will write the Kc expression for this reaction. So Kc is equal to H2O raised to the power 2. Right, students? And here we have hydrogen raised to the power 2 into oxygen. Right, students? Now we write their values in the terms of moles per cubic decimeter. Mole per cubic decimeter, right, students, raised to the power 2 over mole per cubic decimeter raised to the power 2 into mole per cubic decimeter. Mole per cubic decimeter. Right, students? Now in the next step, here we have in the form of denominator 2 plus 1. 2 plus 1 is equal to 3. Right, students? So what should be the next step of this reaction? In the next step, we will write here Kc is equal to mole per cubic decimeter raised to the power 2 over mole per cubic decimeter raised to the power 3, or we can write as Kc is equal to mole per cubic decimeter raised to the power 2 minus 3. Right, students? So it would be, Kc would be mole per cubic decimeter, 2 minus 3 is equal to minus 1. Right, students? So what is the unit of Kc? If you multiply minus 1 with mole, we will have Kc is equal to mole minus 1 dm cube. This is the unit of Kc for given reaction. I hope this is clear to you, students. Now students, we will see what next reaction is given to us. In the next reaction, here we have a reaction, that is the reaction of nitrogen with oxygen to form nitrogen peroxide. In order to determine the unit of Kc, first of all we will write the Kc expression for this reaction. Kc is equal to nitrogen oxide, right, students, nitrogen peroxide raised to the power 2 over nitrogen into oxygen raised to the power 2. Right, students? Or we write their values, that is mole per cubic decimeter raised to the power 2, right, students, over mole per cubic decimeter, right, students, into mole per cubic decimeter raised to the power 2. Now students, here we can notice 2 plus 1 is equal to 3. 2 plus 1 is equal to 3. Now we will write the next step. In the next step, Kc is equal to mole per cubic decimeter raised to the power 2 over mole per cubic decimeter raised to the power 3, or mole per cubic decimeter raised to the power 2 minus 3. Right, students? Or we can write as Kc is equal to mole per cubic decimeter raised to the power minus 1. Now students, we multiply minus 1 with mole, we get mole minus 1 dm cube. Mole minus 1 dm cube. This is the unit of Kc for the given reaction. I hope this reaction is clear to you, students. The unit of Kc is clear to you, students. Now students, we will see what next question is given to us. A chemical reaction is in front of you. Right, students? Bromine chloride decomposes to give bromine as well as chlorine. Now we are asked to write Kc expression. Kc expression for this reaction. So we write the Kc expression. Kc is equal to, what are the products of this reaction, students? Bromine and chlorine. So products should be written as numerator, bromine and chlorine. And what is the reactant for this reaction, students? Bromine chloride. We have bromine chloride. How many moles are given? 2. So it should be written as denominator. I hope this is clear. Now students, in the next step, we are asked to determine the unit of Kc for this reaction. So for the unit of Kc, first of all, we will write the value of Kc for this reaction. That is Kc. Kc is equal to, what are the product of this reaction? Bromine, right, students, and chlorine. These are the products. Then bromine and chlorine, these are the products, right, students? And here bromine chloride is the reactants. Bromine chloride, it is the reactant, students. And how many moles of bromine chlorides are given? We have bromine chloride. And how many moles are given, students? Since we have 2 moles, so here we write 2. Now we substitute their units, that is mole per cubic decimeter, right, students, into mole per cubic decimeter, right, students, over mole per cubic decimeter raised to the power 2. Then we will see what is the next step. In the next step, Kc is equal to mole per cubic decimeter raised to the power 2 over mole per cubic decimeter raised to the power 2. Both the quantities are equal. That's why they will be cancelled out. They will be cancelled out. So it means for this reaction, Kc has no unit. There is no unit for Kc since number of moles of reactants and products are equal in a balance equation. That's why Kc has no unit for this reaction. I hope this reaction is clear to you, students. Now we will see what is the next reaction, students. Next question. The question is, for which of the following reaction both reactants and products are found when reaction is complete? Right, students? 2 reactions are given in front of us, right, students? And we are asked to write the reaction in which both reactants and products are present when the reaction is complete. Right, students? Now let's see what is the first reaction. The first reaction is the reaction of carbon monoxide, reaction of carbon with oxygen to form carbon monoxide. This is the first reaction. Now in this reaction, carbon is burned in the presence of oxygen in the limited supply of oxygen to form carbon monoxide. Right, students? This reaction is irreversible reaction. That's why this reaction is shown with the help of single arrow. This is the irreversible reaction. And in this reaction, product do not decompose to give reactants under the same reaction conditions. Right, students? It means carbon monoxide is unable to decompose to give carbon as well as oxygen. So therefore, reactants and products are not found when the reaction is completed. And जब reaction complete होगा, right students, we will not find the reactants. Reactants मौजूद नहीं होंगे, सिर्फ product ही होगा. Since the reaction is irreversible reaction. I hope this is clear. Now let's see the second reaction. What is the second reaction, students? It is a decomposition of hydrogen fluoride into hydrogen and fluorine. Right, students? This reaction is shown with the help of double arrows, which shows that this reaction is a reversible reaction. That means decomposition of hydrogen fluoride is a reversible reaction, and we know very well reversible reaction never goes to completion, and the mixture of reactant and products are formed because there is a dynamic equilibrium between the concentration of reactants and the products. If we draw the reaction mixture with regular interval, we will find all the three species in the reaction mixture. यानी अगर हम regular interval से reaction mixture को निकालें तो हम देखेंगे कि reaction mixture के अंदर तीनों species मौजूद हैं, all the three species, that is reactant as well as both the products. Right, students? So decomposition of hydrogen fluoride to form hydrogen and fluorine. This is the reaction where we find both the reactants and the products. Right, students? I hope these questions of exercise are clear to you, students.